Here's a question on a photoelectric emission spectrum that's shown here. This is the above diagram, a PES spectrum of a period 4 transition metal. Which subshell is missing from this PES spectrum? Now, a PES spectrum on the AP exam, they're idealized, and basically they're a graph of electron configurations. They're a visual cue as to what the electron configuration is. Now, again, when you hit a question like this, there are parts that you've got to realize in terms of vocabulary, like transition metal. Well, what's a period 4 transition metal? So if that's what they're asking about, that's where we pull up our periodic table, and here they are. This is period 1, 2, 3, 4. Here's the transition metals in 4. So we've got 10 possible answers for this as to who the transition metal could be. And if we're dealing with subshells, we kind of have to figure out what the electron configuration would be for these. So the missing subshell, well, we've got to find what are the subshells. Well, when we do an electron configuration, we do first energy level, and okay, first energy level would be our first energy level, which has a 1s2. This would be a possible answer. This is a subshell, the S subshell. It could be the 1s subshell is missing. Now, in a transition metal, we'd also have a second energy level, S2, and then we would have a P6 because we're moving along, and you can use the periodic table to figure out the electron configurations, but if you're at AP level, you should have these memorized. They're easy enough to remember. They're pretty logical. We would have a subshell, second energy level with 2 electrons and then 6 electrons. Then we'd go to the third period where we would have again a S with 2 electrons in it, and then a P subshell with 6 electrons in it, and we would have moved all the way up to our period 4 transition metal. Well, period 4 has a 4s2, and indeed 4s2. The transition metals do something a little bit unusual. They end up working and filling the third energy level subshell. The D subshells here, the transition metals, start filling in this third possible subshell underneath this 4s. A photoelectron spectrum, as I said, is a diagram of these subshells. And on this diagram, we've got the highest binding energy, where the electrons are pulled in with the greatest force to the left. And on the AP exam, they've said they'll always have this type of diagram where we've got the highest binding energy in terms of usually megajoules per mole, because we're dealing with the attractions between electrons and that nucleus, and they're going to be high. The left to right is the energies, just like we move across here on the periodic table. The same sequence that we have here will be shown in this graph. These outer electrons, these 4s's, are the furthest away from the electron, and they're the ones that leave first. They're the valence electrons. They're not held in. In this case, 1 megajoule. This is a logarithmic graph. It goes by powers of 10. Then we have the height, which tells us how many electrons. So we've got the same sequence here as here, and the height just gives us this superscript number. Well, let's look. They didn't have on the example here, they said relative numbers of electrons, but we know this is going to be 0. If these are our electron configuration numbers, you'd say, okay, well, we've got 2, and then all the way up to 6. So if you've got a S2P6, you'd have one that's 2 and then 6. The height is the number of electrons. And with this, I think you can see we would have a S2P6, S2P6. Now here, again, we've got a 2, and we know that when we're dealing with transition metals, there's a D subshell that's very, very close in energy to the S subshell, higher energy level, right next to it. I think that's going to show you what's missing in this diagram. That's what they're asking. They said, which subshell, energy level, and type of subshell, S, P, or D? Well, I think you can answer that now. And also come up with some other understandings of this PES compared to this electron configuration.